So in this video, we're going to take a look at another way to write some proofs. So there is no warm-up for this activity or this lesson. So what we've done so far is we have learned to write proofs showing that corresponding parts of congruent triangles are congruent by using our 4 shortcuts, and we have been writing these proofs as deductive arguments or paragraph proofs. So what we're going to do is we're going to do an example where we prove that 2 angles are equal, and we're going to do that first by writing a paragraph proof in the first example. Then we're going to look at a different tool for writing proofs, and we're going to use that tool to write the same proof that we write in example A in example B using a different method. And the tool that we are going to use to write the proof a different way is called a flowchart, which you probably have heard of in other classes, maybe even in your math classes. So in our first example, we're going to write a paragraph proof using deductive reasoning. And so we're given a picture over here of 2 triangles, and it says in the figure at the right, EC is congruent to AC and ER is congruent to AR. Remember, when we're given these statements, we want to take our picture and we want to mark these on the picture. So EC is congruent to AC and ER is congruent to AR. Now, it says, is angle A congruent to angle E? If so, give a logical argument to explain why they are congruent. So in order to explain this, what we're going to do is we're going to write a paragraph proof. So we're going to write, again, remember, the first thing you always write in your paragraph proof is what you're given. So what we'll say is EC is congruent to AC and ER is congruent to AR, and we know that because that information is given to us. Okay? Now, if you have picked up on what we have been noticing in these proofs that we've been doing, we also see that these 2 triangles share side RC. Okay? And so what that means is we can say that RC is congruent to RC, and the reason we can say that is because it is the same segment. Now, at that point, we see that we have corresponding sides that are congruent, and we have 3 of them. So what that allows us to do is say that the 2 triangles are in fact congruent. So triangle CRE is congruent to triangle CRA, and we can say that because we are using the side congruence conjecture. Okay. Now, if these 2 triangles are equal, so if this triangle CRE is congruent to triangle CRA, then by corresponding parts of congruent triangles being congruent, or CPCT or CPCTC, we can say, so then by CPCTC, angle A is congruent to angle E, since they are corresponding parts. And so that is what a paragraph proof looks like for this proof. Now, what we're going to do, that's a relatively easy proof, but sometimes a logical argument or a proof is long and complex. And so when writing a paragraph, that might not be the clearest way to present all the steps. So what we're going to do is we're going to show another way to organize our proofs, organize our thoughts, and that is a flowchart. So a flowchart is a visual way to organize all the steps in a complicated procedure in a proper order. Arrows connect the boxes to show how facts lead to conclusions. So what we're going to do, again, flowcharts make our logic visible, and we're going to walk through that same exact proof, but we're going to present our reasoning in flowchart form, creating a flowchart proof. And the way you do this is for every statement that you make, you're going to place that statement in a box, and then you're going to write a reason for that statement beneath the box. So up here, when we said RC is congruent because it is the same segment, the way you would write that is you'd put RC is congruent to RC in a box, and then underneath it you write your reasoning for it being congruent, for those two being congruent. It is the same segment. So what we're going to do is we're going to take this same proof and we are going to write that proof in our flowchart. So again, we know that EC is congruent to AC. We know that ER is congruent to AR. So a flowchart proof would look like this. So we know that AR is congruent to ER. So AR is congruent to ER. We put that in a box. That's a statement that we are making. How do we know that's true? It is given to us. So we just write given. We also are given that EC is congruent to AC. Again, that's a statement. It is given to us. Now, another thing that we know is RC is congruent to RC. Now, this is not given to us, but we know that because those two are the same segment. So, now, these three things together all lead to one thing. And that thing that they lead to is the statement that we can say, because we know these three things, that triangle RCE is congruent to triangle RCA. And why can we say that? We can say that because of the side-side-side congruence conjecture. Now, because we know those two triangles are congruent, that leads to our final statement. We can say that, in fact, angle E is congruent to angle A, which is what we wanted to show, and we can say that because of CP, CTC. So, in a flowchart proof, the arrows show how the logical argument flows from the information that is given to the conclusion that you're trying to prove. Drawing an arrow is like saying therefore. So you can draw flowcharts like this, where I drew it left to right, or you could draw it from top to bottom. Now, what we're going to do is we're going to look at, well, first of all, let's just look at this. What similarities and differences are there in those proofs? Okay. So the similarities are the statements. The statements are all the same, and the reasonings are all the same. The differences are that you have, in fact, it appears that you have less words. There's less reading that you have to do in a flowchart proof than in a paragraph proof. So there is a sort of simplistic feel to a flowchart proof. And also it's visual, so it's easy to see how one statement leads to the next statement, which leads to your conclusion. So what we're going to do is we're going to look at another proof. We're going to use a flowchart to develop this proof. And so what we want to do is we're going to look at this. We have this picture over here. And what we want to do is we want to show that BD is the angle bisector of angle ABC. So we have BD. We want to show that it is the angle bisector of angle ABC. Okay, so let's take a look at this. We're going to write a flowchart. So remember, when you're making these flowchart proofs, you're still doing the same thing that you would with a paragraph proof. You're going to write down everything first that you're given. So here we go. We are given BA is congruent to BC. It's given. We are told that CD is congruent to AD. That's given. Okay? Now, let's take a look at this. This is marked over here. We have BA is congruent to BC. We have CD is congruent to AD. And if you kind of look at it, we have, in a way, two triangles that are being formed over here. We have BAD, and then we have BCD. Okay? Now, if you look at that, is there anything else that we can take away from that? And if you are paying close attention, you'll see that these two triangles do, in fact, share side BD. Now, because they share side BD, what we can say is BD is congruent to BD. Why are we allowed to say that? It's because they are the same segment. Now, we have all this information that we're given. Now we need to say or figure out what this tells us. Now, what this tells us is we have corresponding sides that are congruent, corresponding side that's congruent, and another corresponding side that's congruent. So again, in this case, we have side, side, side. Now what does side, side, side allow us to do? Side, side, side allows us to say that two triangles are congruent. So what we can say is triangle BAD is congruent to triangle BCD. And the reason we can say that is because it is the side, side, side congruence conjecture. Now, at that point, what we can now say is, since we have this side, side, side congruence conjecture, we now can look at see what corresponding parts are congruent. So in this case, what you'll see is we want to show that BD is an angle bisector of A, B, C. So if we can show that angle 1 and angle 2 are congruent, then we are showing that that is an angle bisector. So we can, because of the side, side, side congruence conjecture, we can now say that angle 1 is congruent to angle 2. That is based off of CPCTC. Now that we know that angle 1 is congruent to angle 2, what we can then say is BD is the angle bisector of angle ABC, because it cuts that angle, and since we know 1 is congruent to 2, that means that is the definition of an angle bisector. Okay, so now we have shown that BD is the angle bisector of angle ABC. All right. So again, you can see there is a lot less words than there would be if this was a paragraph proof, and you can see how it flows nicely from what you're given to a conclusion you can draw, to another conclusion that you can draw, to the final conclusion that we wanted to show. Now, let's look at one more example. This one is going to be just a tad bit more involved. It has a lot more parts to the flowchart that we are going to write. So what we want to do is we want to prove the sum of the measures. So we want to prove the triangle sum conjecture, which again, remember, states that the sum of the measures of the angles of a triangle is 180 degrees. So first things first, we need to write down what we are given. We are given, okay, so we're going to write this as a flowchart. Angle 1, angle 2, angle 3 are angle 1, 2, and 3 of triangle ABC. Okay, those are the three angles that we want to prove. And we're given that those are the angles of triangle ABC, so this is given to us. Now, what we want to do, we've talked about this before, how we prove this, is we're going to draw in an auxiliary line. We'll call it KC. So we have an auxiliary line right here, KC. So construct KC, and we want it to be parallel to AB. Okay, that is the definition of an auxiliary line. All right, now what does this allow us to tell us? Let's go ahead and number these. We have 4 and 5. So what we have here now, let's look at all the information that we can draw from this. We know that angle 1 is congruent to angle 4. Angle 1 is congruent to angle 4. How do we know that? Well, we'll get there in 1 second. We also know that angle 5 is congruent to angle 3. And again, how do we know that? It is the alternate interior angles. Okay, they are alternate interior angles. That's a theorem. Okay, and what we said is if we have two parallel lines, which KC and AB are parallel, like we said, and then we have a transversal that intersects those two lines, then we know that alternate interior angles are congruent. So there's one thing that we know. Another thing that we know is that we have, angle 4 and angle 2. So if you take the measure of angle 4 and the measure of angle 2, that's equal to the measure of angle KCB. That is angle addition. Okay. Next, we also know that if we take angle KCB, so this obtuse angle right here, and we take angle 5, so angle KCB and angle 5, those are supplementary. Okay? And we know that because they are linear pairs. Now, let's take that one step further. If we know that angle 1 and angle 4 are congruent, that allows us to say that the measure of angle 1 equals the measure of angle 4. And the measure of angle 3 equals the measure of angle 5. And we're allowed to say that because that is the definition of congruence. And then another thing that we can say is that since we know that these are supplementary, we can say that the measure of angle KCB plus the measure of angle 5 equals 180 degrees. And that is the definition of supplementary. So let me readjust this. I got to make everything a little bit smaller. Okay, so this is the definition of supplementary. All right. Now, because we have this, what we're able to say is the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. Okay, why are we allowed to say that? That is because we are using the substitution property. So coming from this, we know that KCB is equal to 4 plus 2, and then if we add 5 to it, we get this statement. So that is the substitution property. All right. Now, at that point, what we can do is all this information leads to, since angle 4 is equal to angle 1, you get the measure of angle 1 plus we know we have angle 2, so plus the measure of angle 2. And then we have angle 5 is equal to angle 3, so plus the measure of angle 3 equals 180 degrees. Angles 1, 2, and 3 are the interior angles of that triangle. So that is we're using the substitution property, and that is what we wanted to show. We wanted to show that the measure of the interior angles of a triangle is equal to 180 degrees. So that is what a flow chart could look like for that proof. So you guys are going to work on your homework, 1 through 5, 8 through 15. We'll adjust 8 through 15. 8 through 15, we'll make that, you're going to do the odd problems there, and 17. And so if you have any questions, message me on Remind or email me. And remember, these are due on the day of your test.